test 1 2 3 test 1 2 3 okay. Zoom, there is zoom here, no 55. Okay, what else? We're gonna check this. Search account. And we go to this, right? This one, we gotta check the zoom, right? Zoom. Can go to 140. My God, really good. Very good, actually. I no. Let's check the zoom. I think this one. Zoom to YouTube. This is the best one, but it's a different. Okay. And yeah. Marks comment.ไม่มีใครเข้าแล้วโอเค9 ลงแล้วtest 1 2 3 เสียงมานะครับที่ซูมเสียงมานะ I hope that everything is all right. Test 1 2 3 อ้าวเครื่องนี้ test 1 2 3 my god show MV right test 1 2 3 1 2 3นะครับโอเคครับก็ไม่ทราบว่ามีคนเข้ามาหรือเปล่าโอเคoh I need to check you in line B01 like this okay and this microphone too what else what? All right chatting oh we are gonna copy this PS2 does it live or not is it live it's still live right okay copy this and this one right oh this one here right where you can increase the resolution to 1080 okay and this you can increase the resolution to 1040 right okay. Not sure whether it really works or not this one yeah and this one right you're gonna stop need to stop this okay and this is the zoom share zoom okayโอเคมาแล้วครับที่ซูม to YouTube 2 คนครับโอเคoh sorry โอเคเวลาโอเคหวังว่าเรียบร้อยนะครับถ้าใครจะเข้ามาที่เรียกว่าอะไรเรียกว่าที่what is that ที่ซูมนะครับก็เข้าได้นะครับไม่มีก็ผมก็จะปิดพาเนลของซูมนะครับจะไม่เห็นนะครับโอเคมีอลิสานะที่ OBS นะครับไม่ทราบว่าเห็นดีหรือเปล่าครับแล้วก็ที่ซูมนี่มีหลายคนนะครับโอเคโอเค I think good morning everyone welcome you to EE292 right and right I think we have finished the problem about parallel connection right which is this one right เราจบที่ปัญหานี้ถูกไหมครับถูกเนาะแล้วเราก็จะต้องต่อใช่ไหมครับถ้าผมผิดอะไรไปก็บอกได้นะครับโปรดแจ้งนะโอเคนะครับ Oh I need to moment all right ก็เป็นอันนี้ไปนะครับนะครับเราจบตรงนี้ไปใช่ไหมครับน่าใช่เนาะเราขึ้นตรงนี้ถูกไหมครับปัญหานี้ใช่ไหมน่าจะเป็นปัญหานี้เนาะผมถูกหรือผิดครับเท่าที่จำได้ as I can remember what is going on ผมถึงปัญหานี้เนาะถูกไหมครับถูกนะall right okay this one and we're gonna stop this because it's gonna consume the internet bandwidth okay ใช่นะครับผมถึงตรงนี้นะตรงนี้นะครับนะครับโอเคถ้าใครจะเข้าที่ซูมก็ทักมาแล้วกันนะครับโอเคyeah in this problem we have to find the voltage V and IT here okay yeah V is the voltage across this one right and I is the current that passes all these impedances all right yeah we will transform these these 4 boxes into many into the impedances okay the first one the first one is the resistor right ถ้าผมผิดยังไงโปรดบอกนะครับไม่ได้จับนานนะครับเซตเครื่องนานมากวันนี้โอเค5 ohm right you can convert it to the box like this okay which is the ZR right and ZR is equal to R right and it's 5 ohm all right this one นะครับชัดนะทุกคนเห็นนะครับ and what else the next one the next one is the capacitor right capacitor here of course in this case we have VM as 10 volts okay VM equal to 10 volts okay according to this one and the next parameter is omega here okay omega is 4 radian per second all right this one and because this is the cosine function we can say that the phi is 0 okay phi is 0 phi is 0 okay and the next one is that we're gonna need to find the capacitor 0.1 farad here. Okay, we will transform it into 0.1 farad, transform it into the impedance, right? So this is ZC, okay, ZC, and ZC is 1 by J omega C. Okay, it's 1 by J omega is number 4, and here is 0.1. So, and as you know, 1 by J is negative J, right? So you will get negative J 2.5 ohm. All right, something like this นะครับถ้ามีข้อขัดข้องตรงใดก็แจ้งนะครับโอเคนะokay next we will consider the inductor, right? 0.5 Henry. Okay, 0.5 Henry here. Okay, 0.5 Henry, and we will convert it to the impedance box like this, and this is called ZL. Please note that there are two capacitors. This is the first capacitor, and here is the second capacitor, right? So we will say this is C1, right? And here is the C2 will be later, will come later. Here is ZL. There is only a single L, so we will have no subscript for the L at all. Okay, and next one is that we will compute ZL, right, which is J omega L, right? And of course, J is J omega is number 4, and L is 0.5 Henry. You get J 2 ohm like this. Okay. The next one, the last one actually, is the second capacitor, 0.2 farad. Okay. 0.2 farad, right? Like this, and we will get also set, but this is set C2, right? Omega C here will be C1, right? Okay, and here we will have 1 by J omega C2, because C2 is this value. Okay, C2 is 0.2 farad. Okay, the next one is the computation, right? 1 by มีคนจับเข้ามาที่ซูมไหมครับผมไม่ได้ดูนะมีไหมไม่มีนะครับโอเคJ is J and omega is 4 radian per second. C2 is 0.2. We would have here half of these, right, which 2.5 divided by 2, because this is double, okay, this value. So we would have minus J 1.25 ohm, okay, like this. And yeah, we will draw it in the phasor diagram, okay, in the equivalent circuit, right? This one here, okay, what is that? It is 10 cosine 40, right? 10 cosine 40. So we would say this is VS. VS is 10 angle 0. Okay, and we would have 3 boxes, right? Oh, right. Is that correct? Okay, 3 boxes like this. Here, the first box is ZR, which is 5 ohm, right? 5 ohm. And the second box is the capacitor, which is negative J2.5 ohm. Okay, and here we have the third box, which is the inductor. Okay, this one, and yeah, it's already computed, and J2 ohm, right? This one, J2 ohm, and then we will, oh my god, then all of this is connected to this one, right? JC2, which is negative J2 negative sorry นะครับก็จำไม่ค่อยคล่องนะครับกลับมาวันไหลกรอบ negative J1.25 ohm. Okay, this is the equivalent diagram. Today is, I got here. Today is 10, right? 10.10.2022. Okay. Where is the second chapter? ทำไมผมเปิดไม่ได้ Okay, yeah, this is the original diagram. Okay, and we convert it to the phasor equivalent diagram like this. Okay, here, this one, and this will appear like this. Okay, and because we want to find the voltage across the whole 3 impedances here, and also the current that flows in this way. Okay, we want to find the current I here, right? What is that? And the voltage also, yeah, we, okay, like this. Okay, and the next step is that we will combine, okay, all these 3 boxes into a single box. Okay, into set parallel. Okay, not set equivalent. Okay, let's start the diagram. Here we will get again VS, and here is VP, right? V parallel, and here we get set C2, which is negative J1.25 ohm. Okay, and again connected to the source, and VS is 10 angle 0, right? We need to find VP, okay, because VP will be the will be computed from the parallel connection of these 3 impedances. Okay, resistor, capacitor, and inductor here. Okay, VP can be found. Oh, sorry, not VP. I'm stupid. It's ZP, not. Okay, ZP. ZP will be the parallel of those 3 boxes, right? The first one is 5 ohm here. Okay, so we get 1/5, and plus the second box, which is 1/9 negative j 2.5, right? 1 by negative j 2.5. Okay, and plus this. Okay, 1 by j2. Okay, yes, of course, it's going to be 1 by 5 plus here we would have j 0.4. Okay, in here we would get negative j 0.5. Okay, j 0.4, yeah, and there you get 1 by 1 by 5 and negative j 0.1. Okay, and yeah, you can multiply both by 10 and 10. Okay, you get 10 and 10, right? So you get 10 above, and number 2 here and minus j. Okay, because 10 and 0.1 will be number 1. Okay, and here we get 10 and 1 by 5 is number 2. 10 and number 1 is will be 10 here. Okay, ถ้าติดขัดตรงไหนก็แจ้งนะครับโอเคไหมผมไปเร็วไปช้าอย่างไรนะครับโอเคall right that's set P, right? The next one is that we need to reduce this box into a single, these two boxes into a single box, and that's called set parallel, right? Set parallel. Okay, with this box, this diagram, okay, we will reduce it to a single impedance. Okay, here we have the voltage source and a single impedance, and this is called set EQ, which is set P plus set C2. Okay, this is set P plus set C2, and here we can find the current I right now. Okay, I was that, and Vs is still the same. Okay, 10 angle 0, right? Okay, we need to find set EQ in this scenario, but set P for us, oh sorry, set P is shown here 10 by 2 minus j, right? We're gonna need to bring it, bring this complex number to the numerator. Okay, we will get set P, which is 10 divided by 2 minus j, and yeah, you get 2 plus j and 2 plus j, right? The complex conjugate, 2 plus j is the complex conjugate of this denominator, okay, 2 minus j. Okay, and once you get something like this, you will have you get later 10 2 plus j, right? And the denominator will be 2 square. 2 square plus minus 1 square. Okay,ขออภัยนะครับแอร์ร้อนครับขอลดอุณหภูมินิดนึงครับyeah, the denominator, which is the 2 square and 1 square, here the summation of these two numbers will be number 5, right? So you get 10 by 5 okay, and 2 plus j, right? And yeah, the next one is that 10 and 5, okay, we cancel each other, we're gonna get only number 2. So finally we get 2 plus j, right? And we get 4 plus j2. Okay, set p is something like this, but our object is that we need to find our set p plus set c2, which is set eq, right? So set eq will be set p. Set p is this value, right? 4 plus j2 and plus set c2, this value. Set c2 is what we have found before, right? Which is this one, negative j1.25. Okay, you get negative j125, right? So we will get actually 4 plus j0.75. Okay, 0.75. Yeah, it's correct, because this is actually 2 minus 1 minus 5. Sorry for that, I'm too fast. 2 minus 1 to 5, right? So you get 4 plus j 0.75 ohm. Okay, yeah, but it's not this is not finished yet, because we need to prepare it into phasor form, right? Phasor form. What is the common factor we could do that? Otherwise, you need to bring, oh no. Okay, if you go further, set EQ will be 1 by 100, right? And 400 plus j75. Okay, but that is a common factor, which is 25. So we're gonna bring 25 of that, 25 and 100, right? And you have here 16, right? 16, I think. Yeah. Yeah, 16 plus j3, right? And here you would get 1 by 4 only, and the magnitude will be 16 square plus 3 square, right? Which is 3, and the angle of arctan, right? Arctan imaginary 3 by 16. Okay, and yeah, you would get 1 by 4 of 256, right? 256, I think. Yes, yeah, 56 and plus 9, right? And here we get arctan 3 by 16. Okay, here you get 1 by 4 square root of is 5, right? 265. Okay, 265. Yeah, and arctan 3 3 by 16. Okay, and because there is the 1 by 4 and square root of 25 and 11. Okay, there is 11 inside that. Andถูกไหมครับเนี่ย is that correct? No. No. 5. No. No. Stupid. 25 and 5. It is actually number 5. Number 5 and 5, right? And 3. Okay, so there is nothing more, right? So we cannot decompose it at all. Okay, we cannot decompose it at all. Okay, and that's the final result. Okay, this is set EQ. Okay, here is set EQ, and we want to find I, right? In this scenario. Okay, we want to find I, the current in this scenario. We use the Ohm's law. Okay, the Ohm's law says that here you have Ohm's law. Okay, Ohm's law, and it's written as VIR, right? VIR, and the result here can be expressed as I is Vs, okay, divided by Vs, okay, divided by set EQ. Okay, and as you know, Vs is 10 angle 0, 10 angle 0, right? Divided by our set EQ. Set EQ, which is what we have got here, 1 by 4 square root 265. Okay, 1 by 4 square root 265, and arctan 3 by 16. Okay, because we have here 3 and 16 imaginary divided by real. Okay, of course you would get this is square root 5, right? Square root 5. And there you have also 4 of 2 5, right? 2 square root 5 above. You have 4 and 2 square root 5. Because you cancel from here, square root 5 and divided by square root of 53. Okay, and there you get arctan of 0 degree minus arctan 3 by 16. Okay, and yeah, of course you get 8 square root of 5 by 53 and negative arctan 3 by 16. Okay, and that's the angle phi. So therefore you can find IT, okay, time domain for the current. Time domain will be IT, okay, which is IM is 8 square root 5 by 53, and cosine, right? Cosine omega is number 4 here, right? Omega is 4. which is what we have prepared for. Okay, omega is 4 radian per second, so it's 4t, and this angle, okay, minus arc 10 3/16, close the parenthesis. You can use the calculator to find this complicated number. Here you just use Google for simplicity. 8, right, times square root of 5/53. 5 and 53, we get 2457. 2.457, and cosine 4t, and the angle arctan 3/6, right? Arctan 3/16. You get this value, which is in radian. Okay, you can convert it 2 degrees by pi. So it's 10.62 approximately. Okay, approximately 10.62 degrees, and that's okay. And let's check whether our solution is correct or not. เดี๋ยวเรามาดูนะครับว่าของเราถูกหรือเปล่าถูกไหมครับZEQ 4075. Okay, IT is somehow it is right. Okay, yeah, correct. Okay, we get IT, which is 2.45257, cosine 4t minus, okay, minus 10.62 degrees. Okay, that's correct. The unit for the current, I forget it. Okay, ampere. ผมก็ยังลืมหน่วยนะครับโอเคไหมแต่คุณเวลาสอบอย่าลืมหน่วยนะครับตัดคะแนนได้นะครับ Okay, what else? Now let's move to the next quantity. Okay, you want to find V in this scenario, right? Of course, you know that there will be current here, I, which is already known there, right? I, and they want to find V here. Okay, let's say VP. Okay, VP will be found from the Ohm's law again. Okay, VP will be I times at P. Okay, we will find V across those 3 parallel impedances. Okay, VP. VP, right? VP will be from the Ohm's law again, right? Okay, V I Z. Okay, if you want to find V, okay, you get the product of I and Z. Okay, I times Z P. Okay, you cannot use ZC1, C2, or ZL1 or 2 because this current will pass all those 3 impedances. Okay, you cannot use only ZR, ZC1 or ZL. Okay, you have to use the resounding impedance, which is ZP. Okay, ZP, which is what we have before, is 4 plus J075, right? 4 plus J075. Of course, the current is found as this value, right? Is square root 553 arctan 3/16. Okay, we get the first quantity. Where is that? Okay, this one, right? 8 square root 5 by 53, and the angle here is arctan, or we can approximate as negative 1062, right, degree, and ZP is 4, right, and plus J 0.75, like this. But it's better if we convert this one, okay, so that we can find the multiplication easily. Okay, this is 4075, right? Of course, we will leave it like that. Okay, first we convert ZP, which is 4.J075 into phasor form, right? The common factor here is 1 by 100. Again, 1 by 100. Okay. Right. Set. Oh, no. ZP is not 4 plus J 0.7. ZP is 4 plus J2. I'm stupid. 4 plus J2, not 4 plus J075. 4 plus J2. Okay. And 4 plus J2 can still be converted to phasor. And the common factor here is number 2, right? Common factor is number 2, so we get 2 and 2 plus J. Okay, like this. And now we are going to convert 2 plus J to be phasor, right? 2 and the square root of magnitude, which is 2 square plus 1 square, right? And arctan, again, arctan, the imaginary part of this thing, imaginary part is number 1, right? So you're going to get number 1. The real part is number 2. We have here 1 by 2. Okay, so here you have 2 square root 5, and angle of arctan 1 by 2. Okay, and then we could find VP right now. Okay, we substitute ZP to this location. Okay, 4 plus J2. So right now VP will be I, which is this value. Okay, this one. 8 square root 5 53 and angle minus 1062 degrees, and here you have 2 square root 5 angle arctan 1 by 2 1 by 2. Okay, of course square root 5 and square root 5 will be 5, right? So you get 2 and 8 is going to be 16. Okay, 16 and 5, and by 53, square root of 53. Okay, please note that square root 5 and square root 5 will become number 5 here. 2 and 8 will be 16. Okay, and here you have minus 1062 degrees and plus arctan 1 by 2. Okay, พอได้นะครับ พอได้นะ Okay, we're going to leave this VP in the calculator. Okay, in the calculator again. นะครับเมื่อไรมันจะเปิดหลายๆหน้าได้มากกว่านี้นะครับมากกว่า2หน้านะครับ Okay, we have here 16 and 5 will be 80, right? 80 by square root 5353 10.988 988 okay 89 okay and the angle okay angle will be negative arctan 3 by 6 and plus arctan 1 by 2 okay minus arctan 3 by 16 plus arctan 1 by 2 okay you get the result in radian okay in radian but you can convert it to the degrees like this degree I don't know whether it works or no no you have to multiply by 180 and divided by pi 180 by pi 1594 okay 15.945 degree okay and VT in time domain okay we're gonna express it in time domain VT will be the amplitude okay 10 9 8 8 9 and angle also no sorry not angle should be cosine right cosine 4t plus 15 945 degrees okay and unit of this is volt and that's the answer let's check whether it's correct or not you see VT is like this okay 10.9889 10.989 okay approximately and 40 cosine 14 plus 15 945 15 945 okay all right like this นะครับยังจริงๆผมก็นอนน้อยนะยังไม่ผิดนะครับวันนี้โอเค we are still not incorrect โอเคยังถูกอยู่นะครับโอเคwhat is that okay we finish this example and let's go to the next topic okay okay you have already seen the parallel connection you have seen the series connection okay and the combination between parallel and series connection right you have already seen and yeah this is the parallel right next we move to the last topic which is the y delta transformation or you can say it's t and pi transformation okay what happens if the impedances are neither in series nor parallel or in parallel if it's not series and parallel what can we do okay if you unclear about it let's consider this problem how can we solve this circuit is it in series connection or parallel connection แล้วรูปนี้มันต่ออนุกรมหรือต่อขนานเราจะต้องจัดการอย่างไรดีครับ เราจะต้องแบบว่าใช้เทคนิคอะไรเมื่อกี้มันขนานกับอนุกรมผสมกันอันนี้เราจะใช้เทคนิคอะไรดีโอเคไหมเดี๋ยวสรุปภาษาไทยเมื่อกี้นะครับ โจทย์ข้อเมื่อกี้เป็นการต่อแบบโจทย์ข้อเมื่อกี้เป็นการต่อแบบขนานกันก่อนนะครับ3 อันแล้วก็มาอนุกรมครับ parallel first and then series connection with these two. Okay, but in this diagram here, what is that then? Is it series connection or parallel connection? อันนี้มันต่ออะไรเนี่ยต่ออนุกรมหรือต่อขนานครับต่ออนุกรมหรือต่อขนานกัน is it series or or series or parallel connection มันต่ออะไรนะครับอนุกรมหรือว่าขนานนะครับโอเคมาอนุกรมหรือว่าขนานเลยให้เวลาคิดนะครับพิมพ์ตอบได้ด้วยนะอยู่ YouTube ก็ตามทีก็ตอบได้นะโอเค let me capture all of you to the to our line group โอเคขออนุญาต capture คุณนะว่าใครมาบ้างวันนี้นะครับนะครับ EE292 right should I teach this one right oh no this นะครับขออนุญาต capture คุณหน่อยนะเผื่ออินเทอร์เน็ตล่มไฟดับกลางคันนะโอเคyeah no this one noมันเป็นอนุกรมหรือว่าขนานหรือว่าอย่างไรalright ไปแล้วนะก็นี่ด้วยใช่ไหม where is the mouse okay we have 3 people here no not 3 many อลิสาย้ายนะมันอาจจะดูไม่ดีนะที่ YouTube เนาะโอเค alright this one rightอลิสาที่นี่ก็โอเควันนี้นะครับข้อนี้ต่ออะไรครับอนุกรมหรือว่าขนานเนี่ยต่ออะไรแน่ช่วยคิดหน่อยนะครับโอ๊ตช่วยด้วยนะครับ alright this one okay นะ capture ไปหมดแล้วนะครับนะครับไม่มีใครตอบนะเพราะว่าไม่ได้อยู่ซูมนะ YouTube มันกลับมาไม่ได้นะครับAll right, let's continue our story. It's neither series connection nor parallel connection ครับไม่ใช่ทั้งอนุกรมและไม่ใช่ขนานนะครับโอเคไหมความรู้เราก็ยังไม่ถึงนะดังนั้นก็ทำไม่ได้นะข้อนี้ทำไม่ได้ก็ไปต่อครับWednesday Okay, we have to consider a new type of connection, which is called Y connection, or sometimes you can call T connection. Okay, this one can be seen as the letter Y นะครับเหมือนกับตัวอักษร Y นะครับโอเคไหมตัวอักษรตัว Y ภาษาอังกฤษครับโอเคไหมOkay, this one is like the letter Y in English letter. Okay, and if you pull this one up a little bit, okay, it will appear like this, and this looks like the T letter in English alphabet, right? So yeah. It's the same. Okay, this one is called Y connection, this one is T connection, but Y and T connection are the same. Okay, how many nodes are there in the Y connection or in the T connection? How many nodes we have? We haveมีกี่โนดครับรูปนี้รูป Y หรือรูป T เนี่ยมีกี่โนดครับ How many nodes are there in this diagram? Whether it's 1, 2, 3, 4, 5 nodes. How many nodes are there in that diagram? เท่าไหร่ครับกี่โนดดีครับthere are กี่โนดดีครับ how many nodes there are 4 nodes. Okay, 1, 2, 3. Okay, C and D are the same point, belong to the same point because there is no element at all. So 1, 2, 3 nodes, and another node is the node here at the center. This is called the fourth node. So there are 4 nodes in this Y connection. In the same way, okay, the T connection is exactly the same as the Y connection. Okay, there are 4 nodes. Okay, 1, 2, 3, and 4 nodes here. Okay, I hope that you can count it. Okay, you can count it. And the next one on the right side is not the same. Okay, it's not the same as the left side. The right side is called delta connection. Okay, delta it's delta when the apex or the corner is pointing downward like this. Okay, it's delta if you look in this way. Okay, delta means the letter delta in Greek. Okay, delta in Greek alphabet. Okay, and here is Y letter in English. Okay, in English. Okay, yeah. This one is called Y. The left side is called Y connection. The right side is called delta connection. Okay. How many nodes do we have in the delta diagram? How many nodes are there in the ธัญนันท์นะเพิ่งมาครับโอเคไหมธัญนันท์ป่วยเหรอหรือว่าอะไรปกติจะเป็นคนแรกๆที่มาhow many nodes are there in the delta diagram เนี่ยหรือว่าลืมพิมพ์ชื่อไม่รู้เอาเพิ่งมาแน่นอนเลยเพราะเพิ่มเป็น6 คนhow many nodes are there in the delta diagram is it 4 same as the Y connection มี4 โนดแบบนี้ delta มีกี่โนด how many nodes are there in the delta connection of course we have 4 nodes for the Y connection but this is the delta connection it's different okay but you can have also 4 corner like this okay A B C D the same and C and D will belong to the same node right this one how many nodes are there in this diagram มีกี่โนดครับรูปทางขวามือไม่ได้อยู่ห้องจริงก็เลยถามไม่ได้เขียนว่าห้องคุณได้คะแนนน้อยกว่ารุ่นน้องด้วยนะดูแล้วนะครับผมก็ไม่เข้าใจว่าผมสอนไม่ดีหรือว่ายังไงนะไม่มีใครเต็มเลยนะห้องปี2นะครับปัญหาที่1นะครับในขณะที่รุ่นน้องมีเต็มนะทำได้6 คะแนนครับผมก็ไม่เข้าใจว่าอะไรผมเน้นกับรุ่นน้องมากเกินไปหรือเปล่าหรือยังไงไม่ได้เน้นกับคุณครับนะเวลาอยู่ห้องจริงนะครับเรียกออกมาทำเนี่ยควรออกมานะเพราะว่าจะได้เช็คนะครับว่าเป็นหรือไม่ครับพวกห้องปี1ครับถ้าคุณไปดูของเขานะครับแบบว่าจะคุณไปดูห้องเขานะพอเขาจะผมเรียกออกมาทำแล้วเขาออกมาทำเต็มหน้ากระดานเลยนะครับแล้วก็ผิดอุตลุดนะครับช่วงที่หน้ากระดานแต่สุดท้ายก็แก้ให้นะครับโอเคมาแล้วคะแนนสอบกลางภาคมาเขาทำได้ด้วยนะโอเคนะมีเต็มด้วยโอเค how many nodes are there in the right side there will be 1 2 3 nodes okay there are 3 nodes 1 2 3 nodes because we don't have the center point here there will be no 4 nodes okay there will be the 4 node the 4th node okay the 4th node doesn't exist so there will be only there are only 3 nodes 1 2 and 3 nodes okay all right again here we have 4 nodes for the T diagram or T connection okay T will be exactly the same as the Y connection and if you move this one okay to the left hand side you move this one to the right hand side you get the shape like this okay it's like the letter pi okay this is the letter T in English okay T in English right เหมือนตัวอักษร T ในภาษาอังกฤษ oh sorry H and here it looks like the letter pi in Greek okay the letter pi in Greek what is that just go to Google and we're going to look for the pi letter Greek alphabet okay Greek alphabet is something like this okay if you compare this connection to the letter pi in Greek okay you get something like this okay you will see that it looks really similar to that but this one is delta right in Greek alphabet okay this is equivalent this looks very similar to pi letter in Greek. So that's why it's called pi connection. Okay. This is called like pi connection. Okay. But it's exactly the same as the Y. So the delta connection. Okay. Pi is exactly the same as delta connection. Okay. And there are 3 nodes. Okay. 1, 2, 3. Okay. Here you have 4 nodes. Sorry for that. ครับเขียนอันไม่ได้เขียนอันอะไรนะ iPad นานนะครับเขียนไม่ชัดนะครับ and here we have 3 nodes. Okay, we have 3 nodes. Okay. What else? Next, of course, there will be 3 points. Actually, 3 points. 1, 2, 3. 3 nodes. A, B, C, D will be the same, right? A and B, and then C and B will be the same. There are three nodes outside. Okay, if we don't count the node inside, we have 3 nodes outside. So sometimes you may want to convert Y to delta, or in the opposite way, delta to Y. Okay, because in some scenarios, you cannot solve the circuit. You cannot solve the problem by using Y connection or delta connection, especially the delta connection would not allow us to find the currents or to make the circuit analysis easily. So it's not easy at all to deal with deltas. In many situations, we have to convert delta to Y. Okay. In the opposite way, sometimes it's better to convert Y to delta. So let's have a look at the way to convert Y and delta. This is the formula to convert Y and delta. Right. Okay. The way to go memorize or remember this one is called cyclic sum by opposite set. Opposite set. Okay, opposite set. Okay, and this one is 2 adjacent impedance. Two adjacent set divided by some measure. Okay, this is the way to memorize the formula. Okay, you don't have to get into the detail of that. Just use the general way. Okay, and then you can find the conversion formula. Okay, which is a little difficult to memorize, okay, or to remember. Okay, just use this one. This one. Cyclic sum divided by opposite set, or 2 adjacent set divided by summation. Okay, let's have a look. What is that then? No, stupid. Okay, let's have a look at that. What is that? Delta Y to delta conversion, right? If you have Y connection like this, okay, if you have connection Y like this, Okay, you have the Y connection, and the first impedance is denoted by Z1. Second impedance is denoted by Z2. The last one, the third impedance, is denoted by Z with subscript 3. And if you wanna convert this one, the original is the Y connection, right? If you want to convert the Y connection to delta connection, here is the way. Okay, the way is that you just draw it and assume that there will be 3 impedances that appears in 3 impedances that appear instead of the original 3 impedances. Okay, and let's see, yeah, this one, this box, the dashed lines represent the virtual impedance. Okay, this dashed line represent the virtual impedance. โอเคก็คือเส้นป่านะครับจะแสดงเสมือนว่ามี impedance ตรงเป็นรูปเดลต้านะครับแต่จริงๆแล้วมันคือ y นะเราจะแปลง y เป็นเดลต้านะครับโอเค we want to convert the y connection to delta. Okay, let's say this one is called ZA. The lower left is known as ZB. The lower right is known as ZC. Okay, and ZA, ZB, ZC is somehow this. โอ้ทำไมแอร์ไม่เย็นเลย Okay, the original one is Z1, Z2, Z3, right? Original impedances. But we want to convert it to delta connection, right? Like this. And the way to convert is that you have to determine the values of ZA, ZB, and ZC, which doesn't exist, which don't exist, right? But we're gonna assume that it appear in virtual. Okay, so that we can solve the circuit easily. Okay, let's go ahead with ZA. ZA is right here. Okay, ZA is right here, and of course is the cyclic sum. Okay, cyclic sum, cycle sum. It means you just rotate. Okay, Z1 to Z3. In whatever direction. Okay, you may rotate it in counterclockwise direction, or you want also the clockwise direction. You can have any direction. Okay, if we go in the counterclockwise direction, we start from Z1 to Z3, and we're gonna write down Z1, Z3. Because this is the summation, we're gonna have the plus sign. Once you go from when you went from Z1 to Z3, next we go to we go from Z3 to Z2. So you're gonna get Z3, Z2. Okay. And the next one is that you have to go from Z2, the last one, from Z2 to Z1. So here you get our Z1, Z2. All right. And then you get this one, okay, the ratio, and the denominator will be the opposite impedance ภาษาไทยก็คือ impedance ที่อยู่ตรงข้ามนะครับโอเคไหม ZA is here, the opposite box, the opposite impedance is this location, which is Z3. Okay, Z3, we get Z3. Okay, ZA is in the opposite way to Z3. Okay, right. Yeah, somehow it is. So in this figure, ZA, where is ZA is right here. The opposite direction, the opposite impedance of ZA is Z1. That's why we get Z1 here at the denominator. And here, the numerator will simply be the cyclic sum. เคขึ้นอยู่กับรูปที่คุณวาดนะครับว่าวาง set a set 1 set 2 3อย่างไรผมไม่ได้วางอย่างเขานะครับก็วางอย่างเงี้ยมันก็ต้องออกมาเป็นสูตรนี้ครับโอเค now let's consider let's determine set b set b like this okay set b the numerator will be the same okay cyclic sum you start from set 1 to set 3 set 3 to set 2 set 2 to set 1 right you get set 1 to set 3 set 3 to set 2 set 2 to set 1 okay and here you have the denominator because you are interested in you consider set b okay you are interested in set b the opposite impedance is set 2 okay opposite impedance is set 2 so you're gonna get the denominator as set 2 all right and set c you have again the same okay you rotate from set 1 to set 3 set 3 to set 2 set 2 to set 1 the cyclic sum at the numerator will be set 1 set 3 set 3 to set 2 plus set 2 to set 1 and the denominator because you are interested in set c the opposite impedance of set c is this one which is set 1 so we're gonna get set 1 as the denominator okay and this is the so-called y to delta conversion okay y to delta conversion like this okay the next one is that sometimes you want to convert from we have already seen y to delta right in the opposite way we consider delta to y connection okay delta to y connection ไปไหนนี่อ๋ออีกแล้วไปเพิ่มหน้านี่อีกแล้วผิดอีกแล้วนะครับมาก่อนโอเคhere right okay the next one is delta to y connection we start from the delta like this let's say we have here okay and it's called ZA ZB ZC like this okay and what we want to find is that we want to find the y connection like this okay the red one which don't exist in reality but we're going to express it in virtual form in imaginary okay let's say this is set 1 set 2 set 3 okay set is not set 3 all right if you want to find set 1 if you want to find set 1 what is that note that set 1 stays here and there are two impedances near them the first one is set A and the second one is set C okay set ขนาบข้างครับมี2อันนะ set A กับ set C นะครับ we are interested in set 1 okay set A and set C stay close to set 1 so we're gonna get the numerator as set A set C okay and the denominator will be denominator คือส่วนนะครับโอเคไหม denominator will be set A plus set B plus set C okay the summation of all those three impedances set A plus set B plus set C all right okay set 1 is gone. Let's go into the set 2 if we want to find the expression of set 2 will be because the impedances that locate close to set 2 are set A and set B. So we're gonna get set A, set B here as at the numerator คือเศษนะครับ numerator คือเศษ and the denominator will be the summation of all these three boxes. So we're gonna get set A plus set B. Okay, summation ครับรวมกัน3ก้อนครับ set A set B set C. Okay, cascaded by set A set B and set C are cascaded by the plus side. Okay, and now we consider the last one, which is set 3. What is that then? Set 3. Set 3 will be because set 3 has set B and set C beside them. So you would get the product between set B and set C at the numerator, set B and set C. And here we have you have set A, set B plus set C. All right. Okay. And in the slide, if you want to find set 2 will be the product between set A and set C because set C is here, set A is here. Okay, the product between set A and set C. That's why we get set 2, set A, set C. Okay, and the numerator will be the denominator will be the summation of all these impedances. Okay, ได้นะ now let's apply this theory to solve the following problem. Okay, this one เป็นปัญหาสุดท้ายของวันนี้แล้วครับโอ้ผมยังไม่ได้เตรียมสไลด์บทที่3ให้คุณเลยเนาะผมนึกว่าไม่ขึ้นบทที่3เนี่ยแต่ไม่เป็นไรดูก่อนว่ามันจะทันหรือเปล่าครับ Okay, this problem all right I'm not sure whether you can see it as delta or y connection. Okay, อันนี้รูปนี้เป็นเดลต้าหรือว่าเป็น y หรือว่าเป็นอนุกรมหรือว่าเป็นขนาน Does it look like series connection, y connection or delta connection or parallel connection? ต่อแบบไหนครับต่อแบบ y ต่อแบบเดลต้าหรือว่าต่อแบบขนานอันนี้ In figure 13 here ตอบแบบไหนเอ่ยมีใครตอบได้บ้างตอบแบบไหนดีครับตอบแบบอนุกรมขนานหรือว่ายังไงหรือว่า y หรือว่าเดลต้าเป็นอะไรเอ่ยเป็น y เป็นเดลต้าเป็นอนุกรมหรือว่าเป็นขนานครับ okay. Actually there are many ways to solve this circuit. Okay, it depends on how you look at this. Okay, whether it's delta or y or whatever you want. Okay. All right. The common thing, the conventional way is that we're gonna take this angle, try to move this one to stay together. It's gonna look like delta. Okay, and we will convert it to y, and then we get the result later. All right. Okay, let's solve this problem. Okay, let's solve this problem. What is Vm in this scenario? Vm is Vm is 10 volts again. Okay. And what is omega in this scenario? Omega is 4 radian per second. All right. And what is phi in this scenario? Phi is 0 radian or 0 degrees, right? Okay, 0 degrees or 0 radian is up to you. Okay, in whatever you look at that. Okay. All right. Okay. Yeah. It depends on how you look at this. Okay.ผมไม่รู้ว่าคุณเห็นเปล่า yeah, let's go ahead with that. The first one, of course, the 5 ohm resistor. This one, okay, 5 ohm can be converted to ZR, right? ZR, which is 5. Okay, ohm. Okay, the next one is the inductor here on the right side. Okay, upper right, 0.5 Henry. Okay, we're gonna write that. Okay, 0.5 Henry, and you're gonna get something like this. Okay, set L, right? Set L1 because we have 2 L. We have 2 inductors. The first inductor is here on the right, the upper right. The second inductor is at the lower left. Okay, lower bottom. It's 0.0. What is that? 0.8 Henry. Okay, this is 0.5. Okay, we consider 0.5 Henry. We're gonna get set L1, which is J omega L, right? Which is 4 and 0 J2, right? J2 ohm. All right. The third impedance is this one, 0.1 farad in the horizontal way, right? 0.1 farad. 0.1 farad. And you can convert it to the box like this also, right? Is ZC1. 1, this is number 1. 1 by J omega C1, right? If you go ahead with that, it's going to be negative J2.5 ohm. J2.5 ohm, if you calculate it again, okay? The third impedance has already gone, okay? The fourth is this one, 0.8 in vertical orientation, 0.8 Henry inductor. 0.8 Henry. Okay, and you convert it to the, again, the impedance in the vertical. Set L2, right? Which is J omega L2. And you can see that set L2 here is omega is 4, L is 0.8, it's going to be 3.2, right? So this one is J 3.2 ohm. J 3.2 ohm. All right. And the next one is the last one, okay? The fifth one is 0.2 farad. in the vertical way, (0.2 farad, and that's will be converted again to the vertical impedance like this. This is at C2, which is 1 by J omega C2. Okay, and if you calculate it, it's going to be half this one, right? It's here we have J minus J 2.5 is negative J 125 ohm, like this. All right. Yeah, you have already prepared 5 impedances, okay, for the actual. You have already prepared 5 impedances for the actual diagram, and let's draw the diagram in the frequency domain or in the phasor domain. Okay, let's draw it. Like this, right? Okay.มันจะเพิ่มหน้าให้ถูกหรือเปล่านะครับ Okay. Of course, you have the. I don't want it. I want the horizontal diagram like this. Okay. Oh, มันก็ไม่เยอะอีก I got it. No problem. Here we have you have the voltage source, and you get ZR, this location. You get ZL1. Oh, sorry. This is ZR. And here you have ZC1. And there you have ZL2. And here you have ZC2. All right. And oh, sorry. Then it's connected further like this. Okay. All right. And here is VS. VS is VM is 10. Omega is 450, so it's going to be again 10 angle 0. Okay. But in order to go further, we cannot use neither series connection or parallel connection. We're going to use Y or delta connection, right? We're going to draw this figure again in a better way, like this. Here you get VS. I just write VS, okay? And then you have ZR. Okay, ZR. And here you have ZL1. Okay, and further, you have here ZC1. Okay, and there you get ZL2. Okay, and there you get ZC2. All right, like this. Okay. Do you get confused from the original to the adapted one? Okay, you just join this corner to stay together and you're gonna get here. งงไหมครับจากรูปนี้มารูปนี้งงไหมวาดได้นะพอได้นะสี่เหลี่ยมกลายเป็นสามเหลี่ยมก็คือรูปเดียวกันนะมันโหนดเดียวกันนะครับตรงนี้นะโอเค Is it okay for you to get that to understand it? พอได้นะครับพอได้ไหม Oh where is that where is my mouse where is the mouse okay can you get that okay พอได้นะครับพอได้นะ okay and then we will consider only this location this area okay we will convert it to y okay we will consider that area and we draw it as another separated separate figure this okay we are going to use the delta to y connection oh sorry I forget to mention here right I forget to mention this where is that I forget to mention this one is called delta to y conversion delta because we start from delta okay we start from delta the blue one we end up with the red one which is y connection it's going to be called delta to y conversion all right something like this delta to y conversion then for us in this problem we start from delta okay the original connection we will transform it to y connection okay we write it like this let me see it okay here it's delta connection we're going to write it like this okay this is set R this is set R and here we have set L1 and here you get set C1 okay we're gonna express it like this okay okay and we're gonna get like this okay it's time for you now to give a name and give the names to all these three impedances จะเรียกตั้งชื่อมันว่า set อะไรดีครับ set 3 กล่องนี้ okay what should we call it then should it be set อะไรดี set alpha set beta set delta หรือว่าอะไร set gamma set ห้อย1 set ห้อย2 set ห้อย3 set ห้อย a set ห้อย b set ห้อย4คูณ set อะไรดีครับ what should these three impedances be what is the name for that what should it be then เป็น set อะไรดีครับนะเป็นควรเป็น set อะไรดีครับ Okay, let's say this is set A, set B, set C. Okay. Oh no, it should not be set B, set B, set C, because we have also set C1, C2. Okay. Let's say we call set 1, set 2, set 3. Okay. Set 1, set 2, set 3. So what is the expression for set 1? Set 1 หาได้ไง Set 1 just locates here, and there are two impedances beside it, okay, which are set R, set L1, right? So we're gonna write set R times set L1 divided by the summation of all these three impedances, which are set R plus set C1 plus set L1, like this. Okay, and you just substitute the set R set L set C1 too. Okay, what we have prepared before, set R is which is 5 ohm. Okay, 5. Set L1 is L1, right? It's J2, and divided by, okay, divided by these three impedances, which is 5, okay, 5 plus set C1 is this thing, minus J2.5, okay, and plus the last impedance, which is set L1. Set L1 is J2. All right, and you get J10, okay, J10, and you get, sorry for it, you get J10 and here 5 minus J 0.5. All right, and if you multiply the whole thing by 10, okay, 10 and 10, and 10 here too, okay, you would get J100 and 50 minus J5. All right, and you can put the number 5 in front of that. You're gonna get J100, 5 and 10 minus J, okay, and there you get 10 plus J and 10 plus J. Okay, in order to flip this one, okay, flip this one up, we have to multiply by the complex conjugate. Okay, and there you go, because 5 and 100 is going to be J20, right? You will get J20, and of course above there you get 10 plus J, and here at the denominator you're going to have 100, okay, 10 square plus minus 1 square, right? It's plus 1 square, it's the complex conjugate for it, okay, minus 1 square. All right, or 1 square, I'm sorry for that. It's star, yeah, no problem, my God. Yeah, here you would have J10, 10 by that, right? If you distribute J into that, you're gonna get 20 by 100, and number one is 101, right? And here you get -1 plus J10, right? Okay, you distribute J into the factor, into the parentheses here. You have J10, which is right here. J and J will be -1 right here, okay? And this is set 1. All right. Now let's move to set 2. You have already got the value of set 1, which is this thing, okay? 20 by 101. Oh my God. Okay, 20 divided by 101. And the second impedance, which is set 2 here. Okay, set 2. Let's open another page. Okay, we're gonna compute set 2. Set 2 locates just here. And beside set 2, there are set R and set C1, right? Set R and set C1. So set 2 will be set R times set C1. And divided by the summation of all these three things, okay, three boxes. And that's set R plus set C1. And plus another impedance, which is set L1. Okay, set R, of course, is what we know before. Set R is 5. All right, yeah, set R is 5. We get here 5. Set C1 is right here, minus J2.5 or negative J2.5. Minus J2.5. And of course, the summation here of these three impedances is what we have already done here. Okay, 5 minus J 0.5, 5 minus J 0.5. Okay, and again, we are gonna multiply this thing by 10 and 10 for simplicity. And there you get 5 and 25, right? So it's gonna be 125. Oh, sorry. You're gonna get minus J 5 and 25. Okay. And here at the denominator, you get 50 minus J 5. Okay. And you can distribute number 5 at the denominator out of this factor, and you're gonna get minus J 5, 25, and 5 in front of that is number 10 minus J. Okay, and you can see that you can cancel 5 and 5. And again, we need to multiply the complex conjugate. It's 10 plus J and 10 plus J. Okay, yeah, 10 plus J and 10 plus J. Here you get negative J 25 and 10, 10 plus J divided by 10 square plus minus 1 square. Okay, and you're gonna get, of course, you would have 25 divided by 101 in front of that, and minus J and J will be number 1, right? 1. And here you get negative J10 minus J10. All right. And there you go, okay, because we cannot do anything more. And here is set 2. All right, set 2. Oh, stupid. Okay, set 2. We need one more page. Okay. Now let's compute the third impedance, which is set 3 right here. Set 3. Set 3 will be, because set 3 locates here, and on the right side we have set A1. On the left side there is set C1. So set 3 will be the product set A1, set C1 as at the numerator. So you get here set C1, set L1. Okay. Yeah. And the denominator will be the product. Okay. Product set R plus set C1 plus set L1. All right. And once you leave the value for that, right? Because we have already prepared set C1. The C1 is minus J2.5. Minus J2.5, and set L1. Set L1 is J2. All right. And there you get the numerator, which is the summation of all these three impedances. What we have done before is that the summation of all these three impedances is 5 minus J2.5, 5 minus J0.5, not 2.5, okay, 0.5. And the way to do is we need to make it as the integer, right? We multiply above by 10 and the lower by 10. You're gonna get what is that? Negative 10, J will be number 1, right? So this is 5. 5 and 10 will stay there at the numerator, number 10. And here you get 50 minus J5. 50 minus J5. And you extract or try to bring number 5 out of these parentheses. You're going to get 5 and 10 and 5, 10, oh, sorry, minus J. Okay. And again, we can cancel number 5 here. And in order to bring it up, you multiply by 10 plus J again. 10 plus J. Okay, then you get 10 in front of that. And 10 plus J. 10 plus J. All right. 10 plus J. All right. And the lower will be the summation of 10 squared minus 1 square, right? So we have 10 square plus minus 1 square. And then you get 10 by 101 and 10 plus J. All right. Okay, this is set 3 after the conversion here, set 3. Okay, once we get already set 3, we are gonna remove the delta connection and we would have only Y connection, set 1, set 2, and set 3 like that. Okay, the figure, the diagram will change now to we would have the voltage source here, right? And you're gonna get set 1, right? These, okay, and here you get set 2, and there you get set 3, and another one is set C2, set L2 right here. Okay, we get our set C2. We have here set C2 and bring it back to the word source. And here is our set L2. Okay, like this. Okay. Now we can draw this figure again in this way. Okay, we can draw this figure. This is VS, right? Here VS, again VS, and here we have the word source and set 1, right? And we can draw it like this. And here is set 3. Or set 2. And here you have set L1 or set L2, sorry. And there you have set, and there you have set C2. All right, like this. Okay, the figure now will turn into this diagram, okay, like this. Okay, like this. Okay, the way to solve this figure is that we're gonna need to combine these two impedances into a single impedance, okay, and on the right side, okay, we can combine again to a single impedance. Okay, let's draw it again. You have the source like this. Okay, set 1, and here after the combination you get set. Okay, let's say this is set 4, this is set 5. Okay, say this is set 4, and here it's set 5, and this is VS. All right. Okay, so what is set 4 then in this scenario? Because this is the series connection, set 2 and set L2, right? This is our set 4. Okay, this is set, set 4, and here is here is set 5. Okay, our set 4 will be the combination of set 2 and set L2. So set 4 will be set 2 plus set L2. Okay, our set 5 will be the combination of set 3 and set C2. So it's going to be set 3 plus set C2. All right. So let's go ahead with that because we have already found set 2, right? Set 4 is set 2. Where is set 2? Set 2 is this one, 205. Sorry, 25 by 111. It was 101 and 1 minus J10 plus ZL2. Where is ZL2? ZL2 is prepared here, okay, which is the J3.2, okay, plus J3.2, okay, that is for set 4, okay. Yeah. What else? Yeah, that's set 4. Okay, just leave it like this. We're going to use the calculator soon, I think, because the number is quite complicated. Okay. What else? Parallel to, right? What about set 4 in after the calculator? Okay, we're going to use set 4 like this, and set 5. What is that? What about set 5? Set 5 is, or set 3. Where is set 3? We have already got the value of set 3, which is 10 by 101 and 10 plus T. And plus set C2. Set C2 is, where is set C2? Set C2 is over here, which is negative J1.25 minus J1.25. All right. We will use soon the calculator. Okay, we will use soon the calculator. Okay. Okay, 25 101. 25 by 101. 1 minus J10. 1 minus I times 10. And plus I times 3.2. 3.2 is, what is that? Yeah, it's a complex number. As 0.2475 plus J 0.7248, something like that. Okay, what about the set 5? You get 10, right? 10, 1 and 10 plus I and minus 1.25. Okay, and we get 0.99 and plus J 1.35, something like that. Okay. Yeah. Or it's better to use the beta calculator. I'm sorry for that. Let's use Madonna. Input. Or set 4, right? Set 4. Uh, 25 by 101 times 1 minus I times 10 plus I times 3.2 and set 5 10 by 10 by 101 and times 10 plus I. 10 plus I and plus I times the negative 1.25. Okay, let's see the answer. Huh? What? Okay, we need to go to, sorry for that, to source. Source here, okay, we have to leave it here. Let it run. Okay, 0.24752, okay, this one, 0.724, 724 like this, and 0.99, and this is negative, sorry. This is negative. Is that correct? Yeah, it's negative, actually. Sorry for that. It's negative 1.115, blah, blah, blah. Okay, 1.15. 1.15 and negative like this. Okay, what else? That's set 5. Okay, in this figure, we can further combine these two impedances because these two impedances are connected in parallel connection, right? This is parallel connection. Okay, parallel connection. And let's say this is equal to set P. Okay, set P is set 4 parallel, set 5. Okay, now we're going to find set P in this scenario. Okay. Set P could be found from 1 by set 4 plus 1 by set 5 in raises to negative 1. So you're going to get you get 1 by set 4, okay, which is that number, okay, 0.2475 and plus J0.7248. J248. Okay, 1 like this. And you have to add it to another one, which is this number 0.99. 9 and minus J115. Okay, and use the calculator. Find that. Okay, where is that? Okay, set P, right? 1 by set 4 plus 1 by set 5 and raises to negative 1. Raises to negative 1. Okay. Oh my God. Set P without the blank or space bar. Okay. Yeah. Set P appears to be 0.67194 plus J058102. Okay, that's set P. Okay, right now we have the diagram like this. We have the diagram like this. This is the water source, right? VS. And here is, what is that? The first box. The first box is set one, right? Set one. But here set one, and here is set P, right? We get here set one, and the lower one is set P, which is what we have just found here. Okay, set P. And okay, it's returned to another side of the water source, and you can combine these two boxes into a single box like this. Finally, you're gonna get set EQ. Okay, the last box like this. Okay, and there will be I, right, that flows in this way. There will be also I in this way, which is unknown. Okay, I is unknown in this way. Okay, anyway, set EQ, what is that then? Set EQ. Set EQ is the series connection between Z1 and ZP. This is the series connection. Okay, so in series connection, we're going to combine these two boxes, two impedances into a single box like this as the summation, right? So it's going to be Z1 plus ZP. Okay, what is Z1? Z1 is what we have got before, right? Z1 is Z1 is equal to this, right? 10 by 101 and negative 1 J10, right? Z1 is 20 by 101 minus 1 plus J10 and ZP. Okay, ZP is somehow is ZP is something it is 0.67194 7.67.194 plus J 0.598 102. Okay, yeah, and there you get the summation, right? You can use the calculator again. Z1. Let's introduce Z1. Let's introduce Z1 like this. Okay, our Z1 is here 20 by 101 times minus 1 plus I times 10. Oh, sorry. Small I like this. Okay, and set EQ. Okay, set EQ will be Z1 plus ZP, right? ZP. Okay. You see what is set EQ in this scenario. Okay, let's calculate. Okay, there you get, where is my pen? Oh, the pen is right here. Okay,ปรัญญาหัวหน้าห้องไปไหนมาโอเคไหมครับเพิ่งเข้ามาเหรอ Okay, set EQ ZEQ will be 0.47392 plus J 256,122. Okay, but in order to find I, right, because I will be the division between the voltage source Vs by ZEQ. In order to make the division, ZEQ should be expressed in phasor form, right? In phasor, we're gonna find the phasor of this impedance. Okay, let's try to find ABS for ZEQ. This is the magnitude, and R, which is the angle, EQ times line with AD by pi. Let's see, what is that? So we get ZEQ in phasor form as 2.6047 and angle 79 5168 degree. Okay, and because we're gonna find I, right? Because I is what they want to know. I is Vs by ZEQ. Okay, Vs is, as we know before, Vs is 10 angle 0, 10 angle 0 degree. We're going to divide by ZEQ, which is what we're going to get here. Okay, we just got there 2.6047 and angle 79,5168. Okay, of course, I will be 10 by this number, right? That's I. Okay, this is that issue. Oh, sorry. Okay, I will be first thing. Can you copy this? Set EQ phasor. EQ phasor. Is this number? So we're gonna get this one. -1. Absolute value of this thing divided by 10 divided by this. And here is the negative angle, right? So I is something like that. I will be 3.8392 an angle 79,5168 degree, like this. And in terms of time domain, because everything has to be expressed in time domain, IT will be 3.8392 and cosine, right? Cosine, the angle, the omega, the angle of frequency is 4, so it's 4t minus 79,5168. I think it's not correct. Unit of current is ampere, and that's the answer. Let's check whether it's correct or not.นะครับไม่รู้ว่าถูกหรือเปล่านะครับโอเคป่ะเรามาดูกันครับ Let's check whether the answer is correct or not มาดูนะครับว่าคำตอบถูกหรือเปล่าผมพาคุณมั่วแน่นอน Yeah, my God, exactly. Okay, 38392 38392 38392 cosine 4t cosine 4t minus 79 517 5168. Okay, and that's it for this problem. Okay, is it too difficult for you? ยากไปไหมครับข้อนี้12คะแนนนะครับสำหรับสอบกลางภาคนะออกแบบนี้แหละไม่เปลี่ยนอะไรด้วยเปลี่ยนแค่ตัวเลขนะครับโอเคไหมกองเกิงตัว R ตัว L ตัว C ตำแหน่งเดิมเป๊ะนะครับโอเคไหมเปลี่ยนบางสิ่งบางอย่างแค่นี้ครับอันนี้โอ้โชคดีมากผมเมื่อคืนผมก็นอนน้อยนะนอนไม่กี่ชั่วโมงไม่ผิดเลยนะครับโอเคไหมโหสุดยอดมาก alright ดีนะไม่ผิดนะครับไม่งั้นพาคุณหลงงงสงสัยนะครับ alright we still have 40 minutes โอเคเรามี40 นาทีนะครับเดี๋ยวผมไม่ได้เตรียมบทที่3ไว้เลยขออนุญาตเตรียมไฟล์บทที่3ให้คุณนิดนึงได้ไหมครับหรือว่าจะเลิกเลยหรือว่าไงให้คำตอบมานะครับโอเคไหมงั้นก็ให้ผมเตรียมทำไฟล์แป๊บนึงแล้วกันนะครับเดี๋ยวส่งสไลด์บทที่3ให้มันเสร็จแล้วแหละแต่ว่าแค่ใส่ปีพศแค่นั้นเองครับโอเคไหมใส่ปีใส่เทอมให้ถูกต้องนะครับโอเคwe are gonna move to the third chapter. Okay, we finish the second chapter. Okay, the answer is right here. It's already computed in you can check everything. Okay, the value of set L1, set L2, set C2, set 1, set 2, set 3, set P1, set P2, which is set 4, set 5, and this is set parallel. This is set EQ. Set EQ is 0479. Okay, 4739. The same thing. 2.5. Blah blah blah. Okay, the same, exactly the same. 26048. Okay, exactly the same. นะครับถูกเป๊ะเลยนะครับเพราะว่าอันนี้เป็นคำตอบที่คำนวณไว้ตั้งแต่นู้นปีที่แล้วนะครับนานแล้วนะครับโอเคปีแล้วหรือว่าเทอมที่แล้วจำไม่ได้ครับlet me prepare the third lecture the third chapter โอเคขออนุญาตแก้ชื่อปีนิดนึงครับไม่คิดว่าจะหลุดขึ้นบทที่3ได้แล้วนะโอ้สุดยอดมากเก่งมากครับก็ผมก็ไม่คาดฝันนะครับว่าจะหลุดแล้วนะบทที่2ซึ่งเป็นบทที่ยาวมากๆนะครับ Okay, we move to the third chapter. นะครับระหว่างนี้คุณก็เบรกไปก่อนก็ได้นะครับเดี๋ยวผมเตรียมสไลด์แป๊บหนึ่งครับthis one and the second chapter this leave it there. Let's complete this. Oh, chapter is right here. Need this. I can't find. The third chapter. đơn để with S2 so that's my god, what happened? Yeah. Ah, my god, why? 60. Oh, ทำไมล่ะ Yes sir. ทานได้โอเค B01 Sem. Day is today. Is the set no October. October 10. October 10. And current year 1. On site online. But we need the figure. We need the figure. Picture. Second. This. And vertigo. Okay. Yep. file control logo อันนี้affiliation logo sheet all right semester academic year we should have not necessary. It's too long. Yeah, lecture day is necessary. Lecture semester only. Yeah. Space is six. Four, five. Yeah. Oh. Okay.โอเคเรียบร้อยครับเดี๋ยวส่งไฟล์ให้นะครับ chapter 3 right นะครับส่งไฟล์นะครับนี่ iPad โอเคdata yes sir chapter 3 this one โอเคมาแล้วนะครับchapter 3 October 10 right จบบทที่2แล้วนะครับเดี๋ยวเราขึ้นบทที่3นะครับอันนี้เป็นตอนเรียนแรกนะครับคุณ ขึ้นบทที่3นะครับ oh no chapter 3 voltage where is that where oh my data is 2 voltage key in to EE292 in chapter 3 that's the chapter 3 why ทำไมหาไม่เจอครับไม่ก่อน why งงครับว่าทำไมไม่มีโอเคโมเมนต์โอเคwe will open by good note yeah okay right here today is 10.10 okay all right let's start the third chapter okay the title of this chapter is voltage we are going to talk about the potential difference เราจะเรียนบทที่3เรื่องแรงดันไฟฟ้านะครับ okay this is for section B01 okay but this slide is valid also for B03 B04 okay the content in this chapter is something about maze analysis okay we will talk about the theory okay how many steps are there in maze analysis and we will apply the theory of maze analysis to tackle the real problems real diagrams and we consider difficult situation when there is current source because maze analysis is suitable to voltage source okay maze analysis is happy with voltage source what is voltage source is somehow like this one right plus and minus okay or in AC circuit you would have also something like this right VST blah 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 right this is the AC this is the DC right okay yeah there you go you have DC and this but in this chapter we will talk about a simple case okay the DC but the theory of the maze analysis is also valid for the AC case all right you can do it by your own okay for the AC case okay but in this chapter we will consider only the simple scenario which is direct current okay what is the procedure or the theory of the maze analysis you need to be able to find the number of nodes the number of matches or the number of loops in the diagram okay and assume that if we have n loops or n matches we need to assign a name okay introduce the name to the matrix currents, for example, I1, I2, I until IN, because we have n matrices. Okay, the current I should be assigned to each loop. Okay, for n matrices. And we are going to need to assume the direction of the matrix current I1, I2, IN to the n matrix. And after that, we are going to apply the KVL. You know KVL, right? From the first chapter, sum V equal to 0, right? That's KVL. It's the circulation of the current. Okay, you can apply the KVL later. I will show you in the real problem. Okay, in the application, we need to express the voltages in terms of matrix current by using the Ohm's law. Okay, and after that, we're going to solve those in simultaneous equations to obtain the unknown matrix currents. Okay, of the several I. Okay, and that's it for the theory or the procedure of the matrix analysis. Okay, we still have 20 minutes. Let's consider the first example. Like this, how many loops are there in this diagram? รูปนี้มีกี่ลูปครับพิมพ์ตอบหน่อยรูปนี้มีกี่ลูปเลย We're gonna solve this problem, right? I'm gonna open รูปนี้มีกี่ลูปครับรูปนี้มีกี่ลูปขออนุญาตแคปเจอร์หน้าจอนิดนึงครับมีมาเพิ่ม2 คนนะโอเคส่งสไลด์ไปให้แล้วนะครับสไลด์บทใหม่นะเดี๋ยวอัปโหลดเข้าไปที่Google Classroom ด้วยครับ right noมีกี่ลูปครับรูปนี้นะครับมีกี่ลูปเลย If you cannot determine the number of loops, then it's really difficult to go ahead, or even it's impossible. Okay, in this figure, there are 2 loops, right? There are 2 loops in these diagrams. All right. So the capital N is equal to 2. The capital N is equal to 2. Okay, there are 2 loops. Okay, there are 2 loops in this diagram, and we need to draw it. We need to draw this diagram. We have to open the third shutter. Voltage. This. Okay, let's draw this circuit again. You have here plus and minus 15 volt. If you have 5 ohm here, you have 10 ohm. You have plus and minus 10 volt. These and or this, okay. Here is 5 ohm, 10 ohm, 10 volt, and 6 ohm, 4 ohm. And the current will flow in this direction. That's I1, that's I2, in here below is I3. Okay, what they want to know is what is I1, I2, I3. Okay, what is I1? What is I2? and I3 นะครับคนไหนทำข้อสอบมาไม่วัดรูปนะครับจะคูณด้วย 0.75 นะครับโอเคไหมไม่รู้เรื่องนะครับว่าคุณกำหนดทิศกระแสอะไรยังไงนะครับโอเคไหมโปรดใช้มาด้วยนะครับโอเคไหมใช้สิ่งต่างๆอย่างนี้มาด้วยครับ KR โปรดวาดรูปมาด้วยนะครับ KR next we will assign the current, right? Assign the current and the current name too. Okay, we need to introduce the current name and the direction. Okay. First, introduce the current name and their direction. Okay, because n is equal to 2, because n is equal to 2, so there will be 2 loops, right? And what is what are directions do you prefer? Do you want it to rotate in this clockwise direction or in counter clockwise direction? What direction you wanted? คุณต้องการแบบไหนครับพิมพ์บอกผมนะผมจะได้แสดงวิธีทำให้คุณนะครับโอเคไหมยังไงมันก็ออกมาคำตอบเดียวกันนะครับไม่ว่า clockwise หรือว่า counter clockwise นะครับคุณต้องการแบบตามเข็มหรือว่าทวนเข็มนาฬิกานะครับลูปซ้ายเป็นตามเข็มตามหรือว่าทวนหรือว่าตามทวนหรือว่าทวนตาม Okay, what do you want then? For possibility, the first one clockwise and clockwise. The second one clockwise and counterclockwise. The third one counterclockwise and clockwise direction. The fourth one is counterclockwise and counterclockwise as well. คุณจะเอาช้อยไหนครับ1 2 3 4 รูปซ้ายรูปขวาครับผมจะได้แสดงวิธีทำให้คุณโอเค What do you want then clockwise direction เลือกมาครับ1 2 3 4เนี่ยเลือกช้อยไหนผมจะได้ทำให้คุณถูกนะครับให้ถูกใจคุณนะครับ What do you want then ช่วยพิมพ์บอกนะครับอยู่ YouTube นะ5 คนนะครับตอนนี้นะโอเค What do you want then ต้องการแบบไหนครับ clockwise หรือว่าตามเข็มตามทวนตามหรือว่าทวนเลยมันไม่ได้อยู่ห้องจริงเนาะมันก็จะพิมพ์บอกมานะครับพิมพ์บอกมาที่ YouTube 1ค่ะสถิตานะสถิตาบอกว่า1นะคนอื่นไม่มีใครว่านะโอเค clockwise and clockwise okay we will go ahead with clockwise style clockwise and clockwise so this one and this one right clockwise CW okay clockwise and what is the current for the first one you first okay let's say for simplicity this is I1 this is I2 all right okay we have I1 I2 like this and what is the relationship between I1 small I1 and I2 I3 by looking I1 the capital I1 here is what is the relationship to the small I1 I ใหญ่1กับ I เล็ก1ว่าไง The capital I1 is exactly the same as the letter small I1 and what about I2 I2 is exactly the same as small I2 okay and what about I3 because I3 is going down right I3 flows downward so I1 is going down I2 is going up at this branch so I3 will be I1 minus I2 because I2 goes in the opposite way to the capital I3 a small I1 goes in the same direction as the capital I3 so it's going to be positive here okay I2 goes in the opposite direction so we have negative value there all right okay so we need to find I1 I2 I3 then we finish this problem okay okay let's start to go ahead with that in the first loop like this in the first loop we can find the KVL right you start from this location you go up okay you walk and you pass the negative polarity of this voltage source of 15 volts so you're gonna get minus 15 okay and you go further you can go right it's okay you go right and you go with I1 and you pass 5 ohm so it's going to be I1 times 5 ohms okay and after that I1 I1 goes down and it passed 10 ohm. Okay, it passes 10 ohm, but there is not only I1. Okay, there is I2 going up, so we need to write here I1 minus I2, because I2 flows in the opposite way, opposite direction to I1. Okay, so this is times 10, because both currents pass the resistor of 10 ohm. And after that, I1, okay, you go this way. You left this, you left this, okay, and then you go here, right? You left this. Now you will pass the positive side of this voltage of number 10. So we're gonna write down plus 10 and equal to 0. All right. And that's for the first loop. Okay. You need to manipulate this equation. It's minus 15 plus 10 and plus 5 I1 plus 10 I1 and minus 10 I2 equal to 0, right? And there you get minus 5 and plus 5 I1, sorry, yeah, plus 10 I2 minus 10 I2 equal to 0. Okay, and you find the most common division number of 5, 5, 10, 10. So it's number 5, right? So you multiply the whole equation by 5 times the whole equation. Okay, you're gonna get minus 1 plus I1 plus 2 I1 plus 2 I2 equal to 0, right? And you can move number 1 to the right hand side, and here you get 3 I1 and 2 I2, right? 3 I1 plus 2 I2 equal to 1, equation number 1. That's it. Okay, in the first loop, we can get something like this. In the second loop, you need to start from this location. Okay, you start and you go up. Okay, in the second loop, the KVL will say that you go up here, you pass the negative value minus 10, right? Minus 10. Okay, minus 10, and you go up with the current I2. Okay, but there is the opposite current, which is I1 also. So we're gonna write I2 minus I1. You pass, okay, you go up right here to I here. You pass the resistor of 10 ohm. Okay, you're gonna pass the resistor of 10 ohm right here. Okay, I2 goes up, and I1 goes down. So in the opposite direction, which is I1 is negative. We have negative in front of I1. I2 goes in the same way as the leading current. So it's I2 here, positive I2. It passes the resistor of 10 ohm. So we're gonna write down number 10 here. Okay, and you arrive at this location. Okay, where should you go further? You should go to the right side, right? Because this is the clockwise direction. Okay, clockwise direction. You go with I2 and you pass 6 ohm. I2 and 6, okay, IR. And you also you pass this one. Okay, you go this way. You left at this, and you need to go downward, right? Because you need to go downward because this is the clockwise direction. You go with I2, you pass resistor of 4, so it's I2 and 4 and equal to 0. Okay, because you will reach the same point here. Okay. Okay, let's manipulate or let's simplify this equation. This is -10. Okay, -10. And plus 10 I2 minus 10 I1 and plus 6 I2 plus 4 I2 equal to 0. You can see that this is 10 and -10 plus 10 I2 -10 I1 and plus 10 I2. Okay. We have two terms for that, but anyway, there is a common number which is number 10, so we're going to multiply the whole equation 1 by 10, the whole equation.โอ้หมดเวลาแล้วนะครับเดี๋ยวขอจบข้อนี้ก่อนนะครับหมดเวลาแล้วนะอีกนิดนึงนะครับอีกวัน5 นาที 10 นาทีเดี๋ยวขอจบแล้วกันแล้วเดี๋ยวมันค้างนะครับข้างหน้ามาต่อ Okay, you multiply the whole equation, you're going to get -1 plus I2 minus I1 and plus I2. Yeah, you would have 2 times of I2 because yeah, 1 plus 1 will be 2. And this is negative. We move to the right hand side, you're going to get negative I1 plus 2 I2 equal to 1, and that's equation number 2. We have before the first equation right here, okay, 3 I1 and plus 2 I2 equal to 1. Okay, if we subtract equation number 2 by 1, okay, equation 1 minus equation number 2, so you will get 3 I1 plus 2 I2 minus I1, oh sorry, I1 and plus 2 I2, okay, equal to 1 plus 1, right, will be 0. And here we have this, we cancel each other, you're going to get 2 I1 equal to 0, y 0. เข้าไปเป็น1 ลบ 1ได้อะ Am I stupid? ผมผิดอะไรไหม sorry ผมผิดอะไรหรือเปล่าทำไมมันขึ้น 3 I1 minus, right, stupid. Oh, I'm stupid. My God. Right here is not plus, it's minus. Okay, it's minus. Sorry for that. Minus. Okay, so we cannot use the minus anymore. So this one will be plus. okay, plus, and here we will plus again. Okay, we will get we get this one as minus. Okay, minus. So plus 2 is number 2. All right. Okay. Okay. Yeah. It means that I1 is 2 by 2, which is 1 ampere, right? I2 is 1, and we will substitute ครับเดี๋ยวขอให้จบข้อนี้ก่อนนะครับแหมเสียดาย substitute I1 which is 1 ampere into whatever you want. Okay, let's say in equation number 2 we're gonna get minus I1, right? Minus 1 plus 2I2 equal to 1. So it means 2I2 will be 1 minus 1. So this is number 1. So therefore, I2 will be 2 by 2 or 1 ampere. Okay, but it's not the answer. Sorry for that. We need to deliver the actual question quantities, which is capital I. And what we have before is this one, right? Okay, capital I1 is equal to I1. So it means it's right here, 1 ampere. Okay, 1 ampere. And I2 is I2. So it's also 1 ampere. And what about I3? I3 is the difference between I1 and I2. So I3 will be I2 minus I1, which is 1 minus 1, and it's equal to 0 ampere. There is no current flow at all. So that's it for this problem. I am late for almost 10 minutes. Okay. Let's check whether the answer is correct or not. Okay, I1 is 1 ampere. I2 is also 1 ampere. So capital I1 is 1. Capital I2 is also 1. Capital I3 is 0. Okay, that's it for this problem. If you have any question, just let me know, and we're gonna quit the lecture right now. See you next week, and please do the homework. Okay, whether you want the delta to Y connection problem, or you want to do the maze analysis like this. Okay, I'm gonna create the homework in Google Classroom. โอเคนะครับก็วันนี้ก็คงจบไว้เพียงเท่านี้นะครับการบ้านก็คือถ้าคุณอยากทำ y delta นะครับคุณก็ทำนะครับใน Google Classroom นะครับแล้วก็ถ้ารู้สึกว่ามันยากนะครับก็มาทำเนี้ยเขาเรียกว่าอะไรอะ maze analysis เนี่ยก็คือหมุนวนนะครับก็ไปเลือกโจทย์มาหรือว่าโจทย์ในแบบใน lecture ก็ได้นะ lecture note แล้วก็เปลี่ยนเลขเอาอะไรอย่างเงี้ยนะครับโอเคมากมีคำถามอื่นใดก็โปรดถามนะครับถ้าไม่มีแล้วก็จะหมดเวลาไว้เพียงเท่านี้นะครับพบกันสัปดาห์หน้าสวัสดีครับสวัสดีครับ YouTube อาจจะมีดีเลย์นะครับมีอะไรก็พิมพ์มาใน YouTube หรือว่าในไลน์กลุ่มก็ได้ครับสวัสดีครับ